Okay, this is 3.3 day 1, properties of logarithms. The assignment is 407, 2 through 36, evens only. Now, there are 3 basic properties of logarithms: the product rule, the quotient rule, and the power rule, and we're just going to go through those one at a time. Here's an example of the product rule. It says that if you take the log of 2 things that are multiplied together, that is equivalent to the log with the same base of the sum of them individually. So for example, log base 7 of 49 x cubed is the same as log base 7 of 49 plus log base 7 of x cubed. Now that's the basic property. Sometimes you can go a little further because you can take this little section right here, log base 7 of 49, and you can actually figure out what that is as a singular value by saying, hey, what is this equal to? Set it equal to a question mark. So writing an exponential form would be 7 to what power equals 49? Well, obviously that's 2. So you can see we've rewritten our final answer where it's 2 plus log base 7 of x cubed. So, other examples of the product rule, and I've written it up here at the top. We will write this as log base 6 of 7 plus log base 6 of 11. And you might think that, hey, we can simplify that, but actually no, that's kind of it, because there is no power of 6 that gives you 7 or 11. I mean, if this was 36, that would be different, but no, that's it. This one would be written as log of 100 plus log of x. Now, log of 100 is something else. That, remember, when the base is missing, it's default base 10. And then that can be said, okay, what would this value be? So if we take log base 10 of 100 and set it equal to a question mark, what the question is really asking is, 10 raised to what power is 100? Well, obviously that is 2. So this entire value we can simply replace with the number 2. And so our entire simplified expression is 2 plus log of x. Or you could say log base 10 of x, that's fine too. That is the product rule. Now, the quotient rule is very similar to that. It says if you take the log of 2 things that are divided, that is equivalent to 2 separate terms where there's a difference. So here's another example of that. Natural log of e to the x over 15 is the same as natural log of e to the x minus natural log of 15. And again, this one right here, you could say, what is this equal to? Now, the reason I know that that's going to work is because this base is the same as this base, so there's going to be something going on here. So in exponential form, that would be e to what power equals e to the x, obviously x. So I took this and replaced it with x for my final answer, x minus natural log of 15. So here's a couple of examples of that. Log of base 8 of 23 over x can be rewritten as log base 8 of 23 minus log base 8 of x. And that's pretty much it. There are no other things we can, because 8 raised to no power gives you 23 exactly, so we can just leave it that way for now. Now, the other one would be the natural log of e to the 5th minus the natural log of 11. Now this one, remember, when the bases match, that's when we can unravel them really nicely. And remember, natural log is the same as log base e, and our argument is e to the 5th. So this can be rewritten and simplified. So log base e of e to the 5th, we'll set that equal to a question mark and then write it in exponential form, which would be e to what power equals e to the 5th? Well, obviously 5. So I'm going to replace that with just 5. And then the natural log of 11, the bases don't match. The base here is 11 essentially, and base here is e, so those don't match. So we really can't simplify it any further than it already is. So that's going to be our final answer on number 4. The last rule is the power rule, which is a little odd. It's not something you'd think would make sense, but basically if you have a log of some base raised to a power, to an exponent, that exponent can be removed and written as a constant, multiplied onto the whole main term. So here's an example. Log of 1,000 raised to the x, you can take that x and move it into the front, so it's x times log of 1,000. Log of 1,000 is log base 10, and remember, log base 10 of 1,000, you can set that equal to a question mark. So if you have 10 to what power and equals 1,000 in exponential form, that would be 3. So basically this whole thing right here is 3. So x times 3, well, we usually write it as 3x. So here are a few more examples of the power rule. Again, we move the 9 out in front, so this is the same as 9 times the log base 6 of 3. And you cannot simplify that any further because 6 to no power gives you 3, so that's just log base 6 of 3. This one is the natural log of x. I'm going to change this radical to its exponential form. So rather than the cube root of x, I'm going to write that as x to the 1/3. Then I have an exponent I can move to the front. So I'm going to take that 1/3 and I'm going to move it out in front. So it's 1/3 times the natural log of x. Nothing else I can simplify there, so I'm done. And then finally, this little 2 right here can also be moved out in front. So it's 2 times the log of x plus 4. And that's it. This is not interchangeable for anything different. Log of x plus 4, that's it. Okay. Then there is a kind of complicated example on the next page that I don't believe I'm going to have time to talk through. It basically applies these rules one at a time. It applies the product rule and the difference rule and then the power rule, and then it simplifies all the way down. If you look at it in its little individual pieces, it's not quite so bad. So you can see this becomes this, which is that, which is this, which is this. This becomes this, which separates, wait a minute, I'm sorry. This goes here, okay. And this goes over here, which becomes this. So it's kind of like little elements kind of evolving one step at a time. So if you kind of follow, this becomes this, becomes this, becomes this, that's kind of how that all works. So if you break it down into its pieces, it's not quite so bad. Now, that's probably not going to make sense to you right now, but later on as an example, it might. Anyway, let's do some basic ones. Okay, so log base b of x to the 4th, cube root of y. All right, so the first thing I'm going to do is notice that these two are multiplied together. This is x to the 4th times the cube root of y. So I can apply the power rule, or the product rule. Log base b of x to the 4th plus log base b of the cube root of y. Now, whenever you have cube roots, you want to change that to the exponential version. So that's y to the 1/3. Why? Because then we can apply the power rule to each one of these. This little exponent of 4 can go out in front. So that's 4 log base b of x plus, again, this exponent can then go in front now that we have an exponent to work with. So it's 1/3 log base b of y. And that's my final answer. And then the last one, log base 5 of the square root of x over 25y to the 3rd. I'm going to use the difference rule first, or the quotient rule, because I have a division here. So I'll write that as log base 5 of the square root of x minus log base 5 of 25y to the 3rd. And then, because I actually have two things multiplied together, I have 25 and then y to the 3rd, I can use the product rule to change this. In the meantime, I'll write that as x to the 1/2. And then this one, as the product rule says, you can write it as log base 5 of 25 plus log base 5 of y to the 3rd. And then the last step is simply moving your exponents out into the front. So this is going to be 1/2 log base 5 of x minus, setting this equal to a question mark gives you the number 2. And then moving the power in front gives you 3 log base 5 of y. Okay.